Okay, now, so for today we're going to be doing some concave mirror stuff. And so concave mirrors are a bit interesting. We have to have an arrow exactly more or less where I'm drawing it, otherwise this will not work. Okay, now I have different colors. Okay, so for the first arrow for concave mirrors, we're going to draw it somewhere beyond the center of curvature. So we're going to draw an arrow right here. And then that should be straight. It should start on the line. Okay, and we're going to note this is part 1, which is beyond C, or beyond the center of curvature. If you guys are feeling confident, you can try and do this. You don't have to follow me exactly. I'm going to be using rank 2 random rules. You guys can do any other 2 rules if you'd like. All 3 rules will work the same way. It is difficult. So some cases it will be difficult to use the 3rd rule because if you aim this at C, you're not going to hit the mirror at all. So in some cases you are restricted. And for this case, we can only use the first 2 rules. Right? Because I've drawn it too close to C. So if I aim it at C, if I try to use the 3rd rule, I'm not going to hit the mirror. So we're going to limit ourselves to the first 2 rules. But that's fine. 2 rules are enough. We only need 2. So again, I'm going to start ignoring this bottom point over here because I know it's going to lie somewhere on the principal axis. I'm not sure where yet. I will get the image of the top point first. Alright, so I'm going to use my first rule. Ray of light incident parallel to the principal axis. Reflects back through the focal point. And we know a concave mirror converges light, so we're going to have it converging like this. Like so. I think that's okay. So this is rule number 1. Whoops. Is this not? There, maybe that's better. Alright, rule number 2. I'm going to draw my incident ray through the focal point. Like so. And this is going to reflect back parallel to the principal axis. Okay, now we have something that has never happened before. Our reflected rays are intersecting without us having to extend them backwards. Right? And this is what is called a real image. We've not seen examples of real images so far, but this is a real image. Right? Because it is formed by real light rays, and it is formed on the same side of the mirror. Right? So we're going to say this is our object. O for object, and then where those 2 light rays meet is the same tip of our arrow. It's the image of the tip of our arrow, and so we can draw a line back to the principal axis, and that's going to be the image of our arrow. I do have this very, very close to the principal axis. So I'm just going to measure this length of this arrow. So my object arrow was about 1 centimeter in length. My image arrow is about 0.8 centimeters in length, just for the salt purposes. Alright, so we will be salting this. So the size of this image is, yes, no? So again, that's why it looks, maybe on some of your drawings it does look magnified. That's why I took the ruler and measured this. So the object was 1 centimeter, but the image was 0.8 centimeters. So the image has gone smaller, right? So the size will be diminished.
I have a question.
Yes.
If our drawing, on my drawing, it's magnified.
On your drawing is magnified? Interesting. I might have actually done this slightly. Maybe I might be off by a little bit. That's okay. I will get back to you on that. I'm not sure whether it's supposed to be magnified or diminished.
What if we, what if something like this happens on like a test this week? How would you?
There's a correct answer for this. I will leave this blank for now, and we'll get back to it in a little bit. Okay. But this is ray number 1. This is ray number 2. We can, I'm pretty sure, attitude. This we can say for sure. Yes, maybe. Inverted, because it's upside down, right? The image is upside down. Location. What's the location? Yeah. Not on. It would just be in front of the mirror. So we're gonna say in front of the mirror, or more technically, it would be on a screen. Right? It can be any screen. And if you'll remember the demo that we were doing the other day, the concave mirror, we saw the image formed on a piece of paper, right? So that was our screen. So the type of image will be, yeah, real image, and we can see that inverted images are also real. Right? So this is closer to the mirror. Location, we're just going to add image is closer to the mirror than object. We're also going to add that. I'm just going to okay. This is a diminished image. If you have a magnified image, I will take a look at your work later. But I'm 99% sure that this image should be diminished for the location we have drawn it at. Okay? Our second location is going to be at the center of curvature. So we're going to draw an arrow that's exactly on, or exactly on C, on top, right on top of C. So it should be on that line. Very important. Okay, and again, we can't really use a third rule here because we can't draw it's not going to hit the mirror if I try to aim it at C. So I'm still going to use my other two rules. And again, we're going to draw a ray parallel to the principal axis, reflected through the focus. That is rule number 1. Is everybody okay? Can you borrow a ruler? Yes. You'll have to make do. Okay. Second rule is passing through the focus. It's incident, and then we're going to draw this parallel to the principal axis, and we'll see that it meets over here, which is also at the center of curvature. Okay, so after you have drawn this image, how many of you got this image exactly at the center of curvature? People's are a little off. So sometimes it will work if it's at the center of curvature, but this is what we're going to talk about. So we're going to solve this first, What is the size of this image? Can anybody guess what the size will be? Yeah, Dave? Same size. Very good. Attitude? Yeah. Inverted. Location is on a screen, but what can we say about the exact distance of the image in relation to the object? Yeah. Same image is same distance away from the mirror as the object. They should really invent a short form for this. I will think about that. Type of image. Yeah. Why is it virtual?
Oh, real. Oh, yeah.
Because it's inverted, it is a real image. Right thinking. Got slightly mixed up, which is fine. We're also, so many of you will notice that it will not exactly be formed at C, and that's because I formed this mirror using a sphere. Okay, until now we've been drawing mirrors as part of circles, right? We've been saying, okay, this is a circle, and half of that, oh, where am I? Okay, this is a circle, and like we're going to shade this, and this is a concave mirror. We're going to shade this is a convex mirror. So if mirrors are formed with spheres or circles, right, we have what is called a spherical aberration. Alright, so what is spherical aberration? It is the, I'm going to draw an arrow and write it down here. Spherical aberration is the slight, what do I want to call this? Disturbance So if the mirror is actually formed from a circle or a sphere, we have noted that there is a slight disturbance. So it's the focal point actually shifts depending on where the light hits the mirror. So we've said that, okay, for a convex mirror, ideally all parallel rays should pass through the focal point, correct? But in spherical aberration, what happens is, for a concave mirror, if this is the focal point, I have some rays that do pass through the focal point. And some rays that pass slightly, very slightly away from the focal point. That's a bit of an exaggeration that I've drawn over there, if this is the focal point. Right? The rays don't pass so far away, but the point is that they don't all converge on the focus. Alright, and due to this, we have some slight unfocusing of the light rays. Alright, and the solution to fix this is to have mirrors that are formed with parabolas. So, again, I recognize that probably half of you don't know what a parabola is.
We're learning about it in math.
You're learning about it in math. It's a curve, yes. But some of you have no idea what a parabola looks like. It is technically the graph of a function of y equals x squared. That is what a parabola is. Again, I'm saying words that you're not understanding, which is fine. Parabola is basically like kind of like a U-shaped curve. Right? So it's not a sphere, it's more U-shaped. It's like elongated. That's what a parabola looks like. If you have your like y-axis and your x-axis, your parabola looks something like that. So if the mirror is formed as part of a parabola, or like if it's parabola shaped, then the focal point is very accurately defined. This is highly focused. These are called parabolic, I don't know, mirrors. So all commercially available, so mirrors that are used, we use curved mirrors for a lot of things like radio stations and stuff, or TV antennas have that curve. Have you ever seen like a TV antenna? Has like a curved shape. That's basically to receive electromagnetic waves and focus it on that little thing at the center. Are you all thinking of the same thing that I'm thinking of?
Yeah.
Maybe we can...
Satellite dish.
Yes, like a satellite dish. See if I can pull up some images. Yeah, one of these things. One of those things. Right? So we see here that it has electromagnetic radiations hit this and then focus on this point right here. So these are not exactly spherical, they're actually parabola shaped. The equation uses a parabola. So that focuses it exactly on the point. If it's spherical, it's not going to focus as well. It will still focus. We did the activity, right? For a spherical mirror, it does focus, but not as well as a parabolic mirror. Right? And that's why we need that. So that defect, the slight defect, is called spherical aberration. Does that make sense to everybody? Because the mirrors on this piece of paper, the piece of paper that you are all drawing on, was part of a sphere, some of you might have a little bit of defects, but we should know the characteristics will be like this. Right? And sometimes you might get this right, sometimes not. Okay, hopefully your page is not too messy. I don't know if I've included a bonus extra. Yeah, you have one. We need to draw 3 more, so if you want to skip this mirror and go to the next page, that's fine. We have 3 more things to draw, and we have 3 more mirrors on the next page. So you can skip that one at the bottom. If you don't want to skip it, that's also fine. No compulsions. I'm just doing it because my previous page is messy. Okay, part 3, we're going to have our object between the center of curvature and the focal point. So that's going to be our object somewhere in between here. Try not to make this one too big. If it's too big, it might not work. Make this a small arrow if you can. But we are going to do the same thing. Ray number 1, parallel to principal axis, reflected through the focal point. Ray number 1. Following rule number 1. And rule number 2, we're going to pass through the focal point and reflect parallel to the principal axis. Right, so, and we have our image formed right here. And that will be our image. Right, and this is rule number 2 that I'm following. Everybody okay? Take your time. We are gonna sheet to salt this though. Size of the image? Yes. It's magnified. Very good. Attitude, yeah, Dave. Inverted. Location. Yeah. Very good. It's on the screen, and image is further away from mirror than object. Okay. Yep. Real type is a real image, and again, inverted is real. Okay. Pencil sharpener. I don't believe so. I can't see any of them. Oh, yes. I don't know if that works. Maybe it does. Okay. Okay, our next object is going to be at the focal point. So hopefully you guys can start doing this. Actually, these two are the hard ones, so we'll do them together. So again, our first yeah. So we're gonna draw our first rule, or use our first rule. Parallel to principal axis, passes through the focal point. We cannot, in fact, use our second rule here because we can't draw a ray of light that goes through the focal point and will also hit the mirror. So we have to use our third rule, where we're going to aim something at C. You can also alternatively use the semi-fourth rule, where you're, putting one through the vertex and measuring angles of incidence and draw an angle of reflection with the same angle. That's the fourth pseudo rule that we learned. I'm going to use the third one because it's easier. So I'm going to, again, this is not going to pass through C, but it's going to appear to come from C. Right? Right there. It's not going to actually pass through C because we want it to hit the mirror. So we're going to aim it through C. We're going to aim it through C, and then it's going to hit the mirror like that. But then we know it's going to reflect back in the same direction. So that's both arrows on that line. Okay, so now we have two reflected rays. Which side will those reflected rays meet? I'm going to try and extend this one backward a little bit to see if it meets here. That doesn't appear to be meeting. Let's extend it this way too. It doesn't appear to be meeting there. So, in fact, at the focal point of a concave mirror, you do not have an image formed. So there's no need to solve this because there's no image formed. Alright, because we have parallel rays of light. There's nowhere where reflected rays are converging. Sandu, is that a question or are you just stretching? You didn't hear me. That's okay. I will note that the uses for this, if you've ever seen like prison searchlights, when somebody escapes, they turn on a prison light and they like zoom around and try to find somebody. Searchlights use, so when they have it's more like a lens and not a mirror. But, actually that's a good point, that is a lens. Now I think about it. I will get back to you on there's definitely one important use of searchlights, of light at the focal point, but what you have to learn though, that it generates parallel beams of light, which means that there's no image formed, right? Because there's parallel beams of light being shown or produced as a result. Okay, our last one, we're at the end. Our last one is going to be in front of the focus. So we're going to draw something that's around about here. That's going to be our object. Okay, more or less this is the same thing. Rule number 1, passing through the focal point. We're used to this by now, hopefully. Okay, our rule number 2 is going to be interesting. You can, in fact, use rule number 2 where you're aiming it from the focus. Again, this is not going to pass through the focus exactly, but it's going to be aimed through the focus, and then it's going to hit the mirror. Or you can do rule number 3. I think I'm going to prefer rule number 3. It's less, I think that looks better. Right there. So that's rule number 3 that I'm using. I'm going to pass one ray of light through the center of curvature, even though it's not actually going to pass through the center of curvature. It's from the object to the mirror, and it reflects back. So you might have to extend these back for a little bit, but you should have them, those two reflected rays intersecting somewhere on the other side of the mirror. So this is going to be our image. And we'll remember when I came and showed you that big concave mirror, when I put it really close up to your face, what did you see? Yeah? It's a magnified image, but it's upright, it's virtual, it's formed inside the mirror, right? So we can also do the salts for this. Whoops, I forgot to ask, but size will be magnified. What is our attitude? Yeah, Daniel. Upright. Our location. Behind the mirror. Let's be more specific now. Behind the mirror, but also, yeah. I have to write this again. Image is further away from mirror than object. Oh, not too bad. And lastly, type, yes. Virtual, again. Upright images are virtual. And I will also draw your attention to the, so right now we've been talking about correlations between the A and the T, right? Upright images are virtual, inverted images are real, right? We can also draw, yeah?
Are you related SNL together?
Yes, we talked about it briefly yesterday. We are also going to relate SNL. If the size is magnified, the image is further away. So we see magnified image, further away. But if we go back to the images that we were getting here, diminished images are formed closer to the mirror. Even for our convex mirror, diminished images here and here are formed closer to the mirror, closer to the mirror. So S and L have that correlation, and A and T have that correlation. So you don't really need SALT, you just need S and A, the SA, and then you can figure out the L and the T. Yes, back to this stuff. Okay. There we go. That was our last one. And so now, okay, so that was, oh wow, that's a half an hour.